Welcome back to Math for Technology and Part 2 of Section 5.5, the applications for trig. I'm moving on to number 3. We're still working with all of those equations that were given to you at the beginning of Section 5.5. In this one we have a steel cylinder 8 centimeters in diameter and it's to be machined in a lathe. If the desired linear velocity of the cylinder surface is to be 80.5 centimeters per second, at how many RPM should it rotate? So the answer is in revolutions per minute. So I know I have to do something with how many times it goes around and time, which makes me think of angular velocity. So if I go to look at the angular velocity formulas, I have either the angle divided by time or velocity divided by the radius. So let's see what we have. Well, we have diameter, which means we have radius, and we have 80.5 centimeters per second, which is the velocity. So knowing that, we should do the velocity over the radius. So that's going to be our formula. So angular velocity, linear velocity over the radius. So for our linear velocity, it tells us our answer is 80.5 centimeters per second. And our radius, since our diameter is 8 centimeters, our radius would be 4 centimeters. So we're going to divide that by 4 centimeters. Our centimeters are going to cancel, putting us in our angular velocity. 80.5 divided by 4 is 20.125, and we're in radians per second. So I'm actually in my linear or my angular velocity, which is what I want, but they want it in revolutions per minute, which is not where I'm at. So I'm going to do some dimensional analysis. So I'm going to make my table here. Put in what I know. I have 20.125 radians over 1 second. I have to get out of seconds and into m, which is minutes. So we think about what do we know about minutes and seconds. There are 60 seconds in a minute. Since I need my seconds to go away, I have to put my second answer on top. That way they cancel, which is 60 seconds in 1 minute. So our seconds are out of here. Okay, so I've done that change. Now I have to get out of radians and into revolutions. So I know that there are 2 pi radians in 1 revolution. So I have to think, who do I need to put on top and who do I need to put on bottom? In order for my rads to cancel, my radians to cancel, I need my radians to go on the bottom, which means my revolutions go on top. That way my radians cancel. I can look and I see I have revolutions left and minutes left. My answer is supposed to be in revolutions per minute, so I'm in the right units. So now I'm just going to do any multiplication I need. So 20.125 times 60 times 1 is 1,207.5, and that's in revolutions. On the bottom I have 1 times 1 times 2 pi, and that's in minutes. So I'm going to go ahead and do this last division here. So 1207.5 divided by 2 pi. Make sure your 2 and your pi are in the denominator of your division, and you should get approximately 192.2 revolutions per minute. Okay, let's move on to number 4, the last one in this section. We're going to work together. An engine requires 6 seconds to go from its idling speed of 600 revolutions per minute to 1500 revolutions per minute. What is its angular acceleration? So as I look at my formula sheet, I see that my angular acceleration is the angular velocity at the end minus the angular velocity in the beginning divided by time. Now, angular velocity is in radians per second. Ours is in, our information we have is in revolutions per minute. So we're going to be converting again to get in our radians per second. So we'll do one at a time. I'm going to start with the 600 revolutions in 1 minute. I know, and I'm going to keep writing these down, I think that might help, that there are 2 pi radians in 1 revolution. To make my revolutions go away, I need the 1 revolution on the bottom, which means the 2 pi radians are on top. That causes my revolutions to cancel. Now I need my minutes to go away, and I know there are 60 seconds in 1 minute. If I need my minute to go away, I need my minute on top. That way they cancel, which puts my 60 seconds in the denominator. Okay, so I'm at radians per second, so I'm at where I need to be. So now I just multiply straight across. 600 times 2 pi would be 1200 pi radians. 1 times 60 would be 60. 1200 times pi divided by 60 is approximately 62.83. So that is my, see, the 600 is where I started, so that's my original or my beginning amount, so that's actually here. Now we're going to go ahead and do the 1500. It's the same process. So really all we need to do is replace the 600 with 1500. So it's 1500 revolutions in 1 minute. We've already worked out all the rest. It's 2 pi radians in 1 revolution, and 1 minute is 60 seconds. That way my minutes cancel, my revolutions cancel, leaving me in radians per second. 1500 times 2 pi times 1 ends up being 3000 pi. 1 times 1 times 60. 3000 times pi divided by 60 is approximately 157.08. So that was the angular velocity at the end. Now it says I'm supposed to divide by time. It took 6 seconds for that to occur, so I'm going to divide by 6. So I'm doing the subtracting, doing the dividing. So I get an angular acceleration of approximately 15.7. Now let's look at what our units are. We took a radian per second minus a radian per second, which means my top is a radian per second. I divided it by a second. So what happens is I have 2 seconds going on, so my angular acceleration is radians per second squared. Make sure you pay attention to what your units are. Okay, if you still have some questions, let me know and I'll try something else. Have a good day.